Hi, this is Rob Jones with P1 Technologies. Today's demonstration is using the combination of Isilon SyncIQ and Cloud Pools to implement a disaster recovery site where some of the data is actually stored in the Amazon S3 bucketing system rather than being transferred from primary to the disaster recovery site. What will transfer between those two sites is actually the metadata that Cloud Pools leaves behind when it dehydrates a directory into S3, and then that would reduce your total data transfer time and volume from your primary to your DR site. Having said that, let's get started. Now, what we have set up for this demonstration is two small Isilon clusters, 3 nodes each. They're licensed for Smart Pools, Cloud Pools, and SyncIQ, which will be what we're demonstrating. Now, Cloud Pools is considered a sub-license of Smart Pools. You need both to do this functionality because Isilon considers Cloud Pools to just be another storage tier. The first step in the demo is to set up our storage pool, Cloud Pool. So we'll do this with the Storage Pools tab. Let that come up. And then the Cloud Pools, and create a cloud storage account. I'll do this quickly because I've done it before in another demonstration. If you'd like to look at the video, it's available. Just contact P1 and we'll make sure you have access to it. Put in my credentials. Please remember, always keep your credentials secret because that is important. I'm just pulling these from off screen, so it's the clicking you hear. Very quickly see what my telemetry bucket. One of the things you need for Isilon, for S3 Cloud Pools, is you need a telemetry bucket set up in S3. There it is, ISI telemetry bucket. And if everything is correct, we should be able to click this. And the account's been created. Very nicely done. You can confirm this is done in just a second. We'll create now a Cloud Pool on that account. We'll call this the P1 DR pool. Again, you select the type. It's Amazon S3. You can fill in vendor description if you like. There's no need to if you don't want to. And you select the Cloud Pool it's a part of, creating it. And what you should see now is you've created that on your Isilon S3. If we refresh here, a couple of new buckets have appeared, a metadata and a data bucket. That tells us that our Cloud Pools are connected, and we should be ready to move data from the local system to the cloud, which we're going to do in just 1 second. What we have set up for the demonstration is 2 directories on the app data directory of our primary cluster, Group A and Group B. They're essentially 100 files of about 1 meg each. If we look at their size utilization on disk, they end up being about 154 megs of utilized space once you count protection overhead and the like. We'll target Group A as being our Cloud Pool group, and Group B will stay rehydrated locally. That would be our active data. So moving back to the primary storage, let's set a file pool policy to say that this is our policy, pool policy. To say if the path matches IFS app data group A, we'll move that to cloud storage. The Cloud Pools target will be our DR pool. We'll go ahead and encrypt the data before we transfer and compress it to save space and to make sure it stays secure in the Cloud Pools environment. Now, one of the questions we had during the talk on this was the encryption actually happens on the nodes before it goes to S3 or to your Cloud Pool storage. So there's no access on the Cloud Pool side unless you're accessing it via an Isilon cluster node that has the keys installed. Another couple things will change just for the purposes of this. You see under advanced settings there's quite a few changes, but the one I'll change right here is cache expiration. And what this is basically says how long will the data remain hydrated on your file system after it's accessed and the access ends and it's also in the cloud. You might set it for a day or two. I'm going to set it for 30 seconds because we want these to dehydrate just immediately so you can see what's happening as the directory shrinks down. It's not a good setting for production, but for our demonstration, it's what we want. Let's go ahead and create that policy. The policy is created. And now, because we don't want to wait for this to run, this is actually a scheduled process, we'll go ahead over to Job Operations and force it to start immediately. Once again, Cloud Pools is part of the Smart Pools system. So to run a Cloud Pools tiering job, we start a Smart Pools job. We'll go ahead and start it. We'll turn up the impact policy to let it run a little faster. And we'll look at the job summary. And we see that it's executing. This may take a couple of seconds. And what we should see as it's running, if I go over to my Amazon S3 console, we should see in the data bucket, yes, objects are starting to appear. They're relatively small. The files are being divided up into even-sized chunks and populated up into the S3 buckets. They were empty before, now they've got data. The active jobs have completed, so we can look at the job report. And the Smart Pools job looks like it's finished. Very good. Now we'll go back to the storage pools. Nothing much to see, except we see that the summary is good and systems run. Now we'll simply wait out the dehydration time. And what we should see, and look, the dehydration job's already run. This runs in the background all the time. It's simply garbage collecting dehydrated files blocks. They've fallen out of cache, and where Group A was 154 megs before, now that it's been dehydrated to the cloud, it is 2.5 megs, essentially. Nicely done. We look over here on the primary, Group A, to your client, it still very much looks like it exists locally on the file system. In fact, if I were to double click on one, we'll pay the time penalty as it's pulled back from the cloud, rehydrated onto blocks on the cluster, and should open for us. It opened in another window, so I'll drag it over here for you to see. It's in the process of opening still. And there it is. 1 meg of fake Latin text. Rehydrated. If we look on here, du-ks again, we see that the Group A directory is actually increased in size from 2.5 megs to 4.1. That's the rehydrated file system appearing, or rehydrated file appearing on the system. In 30 seconds now that my access has ended, it'll drop off and we will begin to see that drop back down to 0. It's there for now, but we've seen what we can do. In the next step, we're going to implement SyncIQ and move this data from the primary to the disaster recovery Isilon. Now that our data is safely stored in the cloud, let's look at moving it from the primary to the DR Isilon. What we have is a directory, the app data directory on the primary where we've seen Group A and Group B already. And on the DR, we've created an empty app data directory, which will be our landing zone for the sync policy. Let's go ahead and define that sync policy and get it started, because it'll take a few seconds to run. We'll go to Data Protection SyncIQ on our primary cluster, select Policies, and create a SyncIQ policy. Give it a quick name. Notice that the naming conventions are different here than in Cloud Pools. We'll target the source app data directory. It's going to be a synchronized job scheduled to run manually because we want it just for a demonstration. We'll set no criteria for transfer. We want everything in that directory. And our target host will simply be, which is the IP address of the DR cluster, and the app data directory on that DR cluster. Now, the last thing we set down at the bottom, a new SyncIQ parameter when Cloud Pools is active is deep copy for Cloud Pools. When this is set to deny, the Cloud Pools system will transfer only the smart links via SyncIQ from the primary to the secondary. If we change it to force, this would force all the dehydrated data on the primary cluster to be rehydrated from the cloud and transferred as full data sets to the secondary DR cluster. You might use this if you have your DR cluster is running 7.2 or another non-Cloud Pools enabled version of 1FS. And allow simply lets Isilon make the choice based on a couple of factors like modification times to decide whether to rehydrate or not. We want to demonstrate the movement of smart links, so we'll set deny and create the policy. Now then, having done that, we have the policy. It's a manual policy, so we'll start it by hand. There it is. And we'll go to the summary tab and let it run. This will run for just a couple of seconds because it is in fact doing a sync of 100 megs of hydrated data in addition to the 2.5 megs of dehydrated data. So it'll take just a few seconds, maybe up to a minute. In that time, let's take a quick look at the secondary cluster and see what's happened there. The secondary cluster under Cloud Pools, as you can see now, the first thing the SyncIQ job did was create a disabled version of the Cloud Storage account and Cloud Pools account. Now they're disabled because they are not in a state where they can write to the Cloud Pool. They can only read from it. And the read information is embedded in the smart link. So even though they're disabled, we will be able to resolve smart links and read files on the DR side. And if we look at the policies, file pool policies, we've got a disabled version of the P1 AWS pool. And that simply lets us, if we go into DR mode where we enable writes on this cluster, we would enable these policies and that would let us sync updated data back to the cloud. While that's running, let's take a quick peek. The SyncIQ job is finished. It looks like it finished, having moved 98 megs. We got a little bit of benefit of perhaps some space savings or compression there on the SyncIQ. 41 seconds and it's done. So let's take a quick look here. And we now see the ISI DR is got the group A and group B. Looking at group B, 100 files of rich text documents like we expected. Group A, these will be the smart links. There they are, smart links. They look just like they did there. And if we go ahead and open this one like we did in the other, after paying our rehydration penalty from the cloud, we should see on the DR site a read-only version of the same file that exists on the primary. It's open to my WordPad. A few more seconds while it pulls the data, I hope. And there it is. Again, the text. 1 meg's worth, rehydrated on the DR side. Very good. And just to confirm that, we've got a session on the DR site. Oops. In app data, ls shows group A and group B. And if everything is as it should be, group A on the DR site, 2.5 megs. Group B, 1.54 with the protection overhead. Same roughly as on this, it's on the primary. So what we've done is we have dehydrated data from the primary cluster into AWS Cloud Pools. Then we've gone ahead and using SyncIQ moved just the metadata pointers from the primary to the secondary site and shown that you can access it as a DR site data set. Thanks very much for watching. If you have any questions, again, my name is Rob Jones. I'm with P1 Technologies. My email is robert@p1technologies. Feel free to send me an email if you have any questions or would like more information. Thanks for your time and have a great day.